Okay, so this is a rotation about y. Let's see, where did I miss it there? So cosine d 0, sine d 0. What did I miss up? One, two, three, four. 1, 2, 3, 4. 2, 3, 4. Oh, okay. So I clicked right here, which put a stopping point there. So if you happen to click on the side, it'll put a stopping point conveniently in the middle of your code. So don't do that unless you intend to. So as we expect, this provides a rotation about our y-axis, and you can see again that if we use our right-hand rule pointed in that direction, the x-axis is rotating down below the plane, which for me at least I wouldn't necessarily expect unless I remember to apply that right-hand rule. And then our z or our x transformation is the same. It is then 1, 0, 0, cosine d of an angle, sine d, negative sine d of an angle,
Why do you have to put the D at the end of it?
that is just to indicate that I'm entering the angle in terms of a degree. So
Gotcha.
remember the sine function by itself interprets this as a radian measure. The sine d will interpret it as a degree measure.
So we can do the same thing for one, just do sine root 2 over 2. Do the same thing.
Yeah, if you wanted, you could, if you're good enough with using your radian measure, you could go through and just say that you're looking at the cosine of pi over 6 for 30 degrees or pi over 4 for 45 degrees. But frankly, I'm not that good at it, so I prefer to work in degrees just because that's what my 3rd or 4th grade teacher taught me, and it's so. Okay, so then our rotation about x is exactly what, as we expect, we're rotating about the x and rotating in the direction that our fingers roll. So, okay, now what happens when we apply multiple transformations at the same time? This is when it becomes quite important, okay? As I was saying before, if we mess up the order on 2 translation vectors or translation transformations, it's not a real big concern to us, okay? But when we're incorporating rotation transformations in addition, then order becomes very important to us. And let's take a look at why that's the case. Let's go ahead and define another transformation. And what axis do you want to rotate about in the second transformation? This will be from, this will be frame C expressed in B.
So leave an X, make it easy.
You want to do an X? Well, that's boring. Let's do one of the others.
We can do
Z.
Z, A, and B.
Okay, Z is nice and easy,
So
so,
just copy those bottom 4.
yeah, oh, fudge. Let's see how I mess this up. 0, 1, and 3 elements there. Or 4 elements there, and we need to get rid of that.
there.
And now it's fixed, right? Okay, good. So now if I go through and do my rotation from B, or up B in terms of frame A, we should see a rotation about the x-axis, just like we expect. If we then go through and do a rotation of frame C in terms of frame B, we should see a rotation about Y. I'm sorry, about Z. So what we should see is that first thing that happens is a rotation about Z, and then a subsequent rotation about, let's see, X. Okay, so let's see if that's what happens here. Oh, and of course I forgot to actually display. Just because I'm that type of person. Okay. So let's see if we can. That doesn't seem quite right. Because sure enough, we did our rotation. Let me move that down and I'll zoom in on it here. Okay. So sure enough, our first transformation did our rotation about X. Okay. But the subsequent transformation did not go on and rotate about Z like we intend, or, yeah. Our subsequent, oh, no, that,
It did.
Yeah,
just
it did,
shows like
right?
that weird red.
So-
Yeah, that blue.
yeah, exactly,
It
so,
shows like, yeah, that little red right there shows the rotation, and the red up shows.
exactly, so, what's going on here is since our first frame rotated about our x-axis, we rotated about the x-axis appropriately, and then this becomes our new z. Our subsequent transformation then is rotating about our new z by the 45 degrees, so we rotate about that z 45 degrees and end up with this resulting frame. Okay. Now if we change the order, just to demonstrate what happens here, you'll see that the order is definitely important.
The Y remained constant on that, right?
Yes, in this case the y does not change. Okay, now what happens?
And rotating the whole frame every time?
In this case, it's absolutely rotating the entire frame. And this is what distinguishes these XYZ fixed angle transformations to what are known as Euler angle transformations. So in one case, you're rotating relative to the fixed frame, which is your frame A. In Euler angles, you're going through and rotating relative to each successively new frame. And that's very important to keep in mind, okay? As we proceed, when we're talking about rotations, we will be talking in terms of Euler angles rather than the Pitch-Jan-Z angles. Once we get to that point, really all we'll have to do is make sure that we set up our matrices correctly in order to get the job done, okay? So how are we feeling on this stuff? Tomorrow then what we'll start doing is start looking at our frame definitions and defining both a rotation and a offset or a position vector for each of our frames and looking at what happens when we move around. Now, just like as is the case with our joint locations, when we define a joint, we're going to want to move along a single axis or a single a single angle. So we're typically going to be rotating about our z-axis. For much the same reason, when we find an offset vector, we're going to try to do everything we can to have that offset occur in a single direction, okay? Commonly, what we do is we define our offset. So in the case of the robot, we define the z-axis radiating through the joint, and then our cost of x-axis along the arm, or along the subsequent section. That means that our position vector for our homogeneous transformation is going to look at something like just our x, the length of our segment in the x parameter, and then zeros filled in the other two parameters. And what that does for us is it takes another step forward into making the algebra very nice and easy to calculate with these transformations. That makes sense? Okay, so with this, I'm pretty much out of time. I'll quickly pull up the assignment so that you can see it real quick. On the videos, I might try to use my wife's camera, but she wasn't real fond of that. But what happens on the segments is that each segment will be an hour long for those of you that are watching these. At the end of that hour, the camera will automatically create a new segment. So you'll have to watch the first hour of the video and then jump to the second video that'll represent the remainder of the lecture. So I'll just pull it up. It's located under assignment 2, just as you might expect. I will go ahead and pull it up just through the directory structure to save us a little bit of time here. So we have assignment number 2. And I provided some directions here just to help clarify what I was looking for. At this point, you can easily do problems 1 through 3, get those knocked out. You have an option to either do everything on MATLAB. If you do, just provide your code, or you can go through and paper and pencil parts of it and only do the parts that specify that you do it in MATLAB. So the first one is very similar to what we did in the warm-up this morning. Second and third one is almost identical to what we did in the homework this morning. And then problem number 4 is going through and determining an unknown segment or transformation given a series of transformations you know. And from there, then we go through and start getting stuff that you've already seen, but we'll formally cover tomorrow in class. So by Wednesday, anyhow, you should be able to go through this assignment. Any questions on it? Okay. We'll see if anyone is going to be out of town and missing class on Thursday for the holiday. Please let me know. If it looks like we're going to have a significant number of people gone, then what we'll do is just use Thursday as a work day. Because ultimately this assignment's long enough where I can see the need for you guys to have a work day just for me to help you answer some of the questions on it. For the work days, I will not be recording those days, so if you are planning on doing this at home and you need help with a particular question, you'll need to email me. So with that, are there any questions? Not quite the full 2 or hour and a half, but frankly, I think that anything over 50 minutes just kind of leads to saturation anyhow. So
you're saying Thursday's a work day?
If I hear back from enough people, then if enough people have plans for the holiday and contact me, then we'll look at using it as a work day. I imagine there's going to be at least 3 or 4 people out of town, so I can almost bet that it's going to be a work day. So, okay, so with that then, we'll stick a fork in it, and I'll see you guys tomorrow.